today it will be a very important class for you all. We will be learning some important concepts which will be very much useful for exam, and also it will be very much useful for concept making. So let's begin with our discussion. In our previous class, what we had did, actually I have given some questions for homework. Anyone tried this question? I have given homework in last session, yesterday. Anyone who has tried this question? Anyone who has tried this question? Reply. Anyone who has tried this question? Answer, please. Any answer? Okay. I'm discussing the question. Okay. Now, what was the question? Question was, there are 4 charges. System of charges having 4 charges. That was plus Q, minus Q, plus Q in the as shown in figure. You can see in the figure. It is given 4 charges like this. System of charges like this. They are here plus Q, minus Q, and plus Q like this. It is telling that potential will be 0 at which point. Yesterday I have given an example and a short question also regarding this concept. You can see that if we are checking at this point E, you can see that this charge Q, it is midpoint of A and B. So for A and for B charge, this will be a 0 potential. They will cancel each other. If we are checking from this point, this charge, you can see that this distance and this distance both are same. You can see R and R. So it will have positive potential and negative potential here, and this will have positive potential here. That's why we can say that at this point charges potential will be 0. Net potential will be 0. At E, same at F, same at G, same at H. So at point E, F, G, H, and at O is here. We can see that at O point, distance from each charges are same. We can see that R1, all are same. We can see that all are same. If they all are same, that means at point O charges, the potential will be 0. So we can say that answer will be A. Any question? Any problem? Okay. Let's move to second question, which is very important. And this question is taken from S.C. Verma book. Actually, this is very much important question. This is a very much important question, and it is taken from S.C. Verma, Concept of Physics. Very good question. It is telling that some equipotential surface are shown here. These are equipotential surface because at each point, at any point on this line, on this surface, potential will be 10 volt only. And for this line also, at each point, at any point, potential will be 20 volt only. Here, at each point, potential will be 20 volt. At each point, potential will be 40 volt, like this. So it is telling that they are equipotential surface. Question is that what can you say about the magnitude and direction of electric field? We have to comment on the direction and magnitude of electric field. So we know that by a concept, we know that electric field is always, yesterday I have taught you that if we have this field lines, this type of field lines, then we have electric potential surface like this, perpendicular to field lines. Okay. Now, if we draw perpendicular here like this, potential here like this, perpendicular here like this, all are perpendicular like this, perpendicular to this line, perpendicular to this, then this will represent electric field lines. What it will represent? Electric field lines. Okay, and these are EPS, equipotential surface. So now we have to find what will be the magnitude and direction of electric field. We know that E is equal to minus dV by dr, that we know. Or we can say that it is equivalent to delta V by delta R, change in voltage, potential, or change in the distance between the two potentials. So what is this? It is given that potential is changing from 20 volt to 20 volt. Finally, it is 10 volt, and initially it was 20 volt. So we can write final mass initial 10 minus 20 like this. Okay, one minus sign here. Now we are telling that delta R, we can say that delta R means this distance, delta R, we can find it by this. This is 10 centimeter. Considering this triangle, it is given, it is 90 degree here. We can see that it is 10. It is, we have to find this angle. So we take sine of this, sine of 30 degree. Sine of 30 is equal to perpendicular by hypotenuse, that is 10. We can write here delta R is equal to 10 into sine 30 will be 1 by 2. That means 5, and it is 5 centimeter. We can write like this, 5 into 10 to the power minus 2 meter. We will write here 5 into 10 to the power minus 2. We will get from here the magnitude. Now we have to think what will be the direction. How we have determined that direction will be in this direction. It can be in this way also. So yesterday I taught you, in the direction of electric field, if we are moving, potential decreases maximum. You know, in the direction of electric field, potential decreases maximum. You can see in this direction, if we are moving, in this direction we are moving, in this direction we are moving, we are seeing that potential is decreasing from 20 to 10. We are moving in this direction, then potential is moving, decreasing from 30 to 20. That means electric field will be in this direction only, because we can see that electric field is in this direction, because potential is decreasing in this direction only, from 40 to 30, from 30 to 20, from 20 to 10. So we determine that electric field direction will be this, and we can find it by using some trigonometry like this. Now how we can find? We can take a value like this. We will use a vector concept. Vector by vector we know. By vector we know one concept. Let's use vector concept to find direction of electric field. We can say direction of electric field, regarding direction of electric field like this. Okay. Now for electric field, what we will take? We will take this angle. Let us consider this angle. This is the same angle with this, same angle here. So because it is figure is very much looking very much tight here, so we are taking this. So this angle will be, we know this is 90 degree. So total angle will be 90 plus 30. 90 plus 30, that means 120 degree. Okay, now we will write our answer like this. How we will write our answer? We will write our answer like this, that value of electric field is this much, value of electric field is this much electric field. We will get some electric field, this much Newton per Coulomb, at angle of 120 degree from x axis, that is this. Okay, this is the most important question, remember. Okay, now let's move further. Today we are going to discuss very important concept, so be careful, dear students. Now we are discussing here what is electric dipole. Believe me, this is very much important question, and many of the questions have been asked from this topic, electric dipole. What is electric dipole? Here is some short definition of electric dipole. You can see short definition of electric dipole. Okay, what is electric dipole? It is telling that if we have two charges, one is plus q, another is minus q, and they are separated by some distance. Let us say it as d, such that this is very small distance. If we take a midpoint and some distance r here, r, and name this point as p. So we define like this. This r will be very greater than d. We can compare the distance between the charges are very less. When equal and opposite charges separated by very small distance, then the constituents, then the arrangement is called as electric dipole. This is electric dipole. Electric dipole. This arrangement. And by definition, we name that electric dipole moment. It is a vector quantity. We name that electric dipole moment. Let us suppose this is plus q and it is minus q, minus q. Electric dipole and distance is d. The electric dipole moment p is defined as q into d, where direction is taken from, important, very important, direction is taken from minus q to plus q. Direction is taken from minus q to plus q. That means we will have this direction of p vector, dipole moment. So remember, this is very important concept. You should remember. Also, for dipole, for electric dipole, we should know one more thing also. For electric dipole, we are knowing that it is a system of charges having two equal and opposite charges. We calculate electric potential, electric field for this dipole arrangement. For this, we take some reference. Suppose this reference line is called axis of dipole. What it is called? Axis of dipole. And this is called axis of dipole, or it is called as side-on position. Side-on position. Okay. And the perpendicular to the midpoint, this is called as equator of dipole. Equator of, these terms are used in question sometime. So remember, equator of dipole, or it is called as broad side-on position. Side-on position. Okay, broad side-on or broad in-on position. Both words can be used here. So remember, for equator of dipole, we have to take angle as 90 degree, and for side-on position, for this we have to take theta is equal to 90 degree, and for side-on position we have to take theta is equal to 0 degree between the charges. We will take it for the reference. Now let's move further. We will use this further. Now we are discussing about electric potential of a dipole. Remember, this is a very important concept. I will teach you. I will skip the derivation part because it is important for board exam, and we are focusing on NEET exam. That's why. Let us take minus q and plus q. They are separated by distance d. If suppose we have to calculate at a general point r, this angle is theta. At this point, we have to find the electric potential of dipole. We define as V is equal to P cos theta by 4 pi epsilon naught r square, like this. This is electric potential of dipole, or we can replace P by QD because P is electric dipole. QD cos theta by 4 pi epsilon naught r square. Okay. Any problem till now? Okay. This is electric potential of a dipole. Okay. We will calculate for different special cases also. Okay. Now let us move further. I am discussing electric field of dipole. It is very important topic. Very important. Remember, it is very important topic. Very important. Now, if we are having two charges system, that is minus q or plus q, we can take either way, or plus q minus q inside, separated by d distance. From here we are taking at a distance theta, at a distance r from here, point P. If we are trying to find the electric field at this point, we will find electric field in two components, because we know that electric field is a vector quantity. It is a vector quantity. We have to use the rules of vector. So we will find the electric field first of all in this direction, and we will call it as ER, electric field in R direction. And we will find this in this direction, and we will call it as E theta. Along direction of theta, we will call it as the E theta, and along the direction of R, we will call it as ER. So what we will get it like this here, ER is equal to 2p cos theta by 4 pi epsilon naught R cube. This will be the electric field in R direction. You can see here R direction, and I am skipping the derivation because it is not important for your exam, our NEET exam. It is focusing because it is important for only board exam. So I am taking that question. I will focus on question and concept only. And if we are going to find E theta, what we get? P sin theta, P sin theta, and P sin theta, and 4 pi epsilon naught R cube. Okay, this is in this direction, and in this direction we find like this. Now, since electric field is a vector quantity, what we will do? We will find the vector addition. They are mutually perpendicular. We will find like this: ER square plus E theta square. What we get? We get P cos theta, P by 4 pi epsilon naught R cube under root 3 cos square theta plus 1. Remember, this is very important formula. We will be frequently using it. Very important formula. Very important formula. Remember this. This is magnitude of electric field. What we get? P cos P by 4 pi epsilon R cube under root 3 cos square theta plus 1. From where we have got this? When we put all this value here, we will get this formula. So remember this. First of all, this formula. Second, to find the angle, because it is vector quantity, we have to find the angle. For angle, let us suppose these two vectors will add up together and give the net electric field in this direction. This is E. What we have found here, E, this E, it is this E. And if let us suppose this is angle is alpha, we can define like this: tan alpha is equal to, like this, tan alpha is equal to, we can take we know by vector addition, tan alpha is equal to P cos P sin theta by P cos theta plus P cos theta plus Q, like this. You know formula. So similarly, we will use E theta by ER. Since they are mutually perpendicular, we will put theta is equal to 90 degree. We will get this formula. And when we will put this value E theta and ER, what we will get? We will get half of tan theta. You can put and find out the formula. This is very important formula, and you have to remember this. Very important for your exam. Very important. What is the formula? We will using this in our special cases also. Please remember this formula. Okay. Any problem till now? Any problem till now in understanding the formula or how it is received, how we have got this? You can ask from me, and I will wait for your response in 5 seconds. You can ask any question till now. Any question. Any question from anyone you can ask. Okay. Now, let us move further. Special case. Very important for your exam, NEET exam. First, I have discussed with you axial position. Axial position. Let us suppose we have said it is plus Q, it is minus Q, and distance is D. We are discussing about axial position. This is axial position I have discussed with you just before one topic. Axial position, or it is called as end-on position. End-on position we have discussed. Now, if we are finding electric field or electric potential at any of this point, we can say that at this point theta will be 0 degree. Yes, yes, yes. Aman, please ask your question. Aman, ask your question. Aman, you can ask your question. Very good. Yes, Aman, you can ask your question. Oh, I think. Okay, no problem. Aman, if you have any problem, you can write a message also, no problem. Okay, no problem. When he will come, he will ask question. Okay, now axial position, we can write here E. What will be E? E will be P cos theta. We have learned here 4 pi epsilon naught r cube under root 3 cos square theta. Cos square 0 plus 1. What we will get? This will be 1 plus 4, 2. We will get 2p cos theta. 2p, not cos theta, 2p by 4 pi epsilon naught r cube. Okay? Or we can write it like this: 2p is replaced by qd by 4 pi epsilon naught r cube. This will be the electric field at axial position, magnitude. And if we are talking about angle, what will be the angle? Tan alpha is equal to half of tan theta. Tan theta is 0 degree. That means it will be 0 degree. What it is telling that if we are finding the electric field at any of the position on the axial direction, we will get electric field along this side or along this side. Any direction. It is parallel or anti-parallel. First of all, how to calculate this? Usually, it will depend upon the magnitude of the charges because they are equal, but it will depends. Okay. In some of the question, I will show about the direction also. It will either this side or this side. Now, electric field direction 0. It means on the direction of axial only. And what will be its value? Value will be this for axial position. Second special case we are dealing with, which is equatorial position, equatorial position, or it is called as broad end-on position, broad end-on position. What we say like this: if we are having two charges, plus q and minus q, and if it is we are having a point which is mutually perpendicular at this point P, we are having theta is equal to 90 degree. What we will get electric field? Electric field will be P by 4 pi epsilon naught r cube under root 3 cos square theta. We know cos square theta, it will be cos 90 0 1, only 1. We will get P by 4 pi epsilon naught r cube. You should remember this formula only, and we can replace here 0 degree. Then we will get for axial position, and if we replace here by 90 degree, we will get equatorial position. This will be the electric field for at equatorial position. And when we are talking about angle, we will write tan alpha is equal to half of tan theta. Tan theta is 90 degree, and tan 90, I think it is infinity. Tan infinity, that means we are telling that it is infinity. That means alpha is equal to 90 degree. Okay. Any problem till now? What it is meaning? It means that from here electric field will be in this direction, here 90 degree. Any problem till now? Any problem? Nandini, any problem from your side? Anyone, any problem? These are very much important concept which we are discussing now, and we will frequently using this concept in a numerical also. Yes. Okay, good. No problem. Okay, no problem. Okay, now let us move further. We are moving further. Okay, let me see what is happening. Sir, sir, can revise from first once again. Now I, Nandi, that's good. But I think you can see the video from beginning also. It is available there. So because we have to complete lots of topic and we have a short span of time. Okay, till now nothing we have done. We are discussing about electric dipole. Just discussing about electric dipole. Just we have discussed about electric dipole. No, not anything. One homework which I have given to you all. To you, electric dipole, electric field of dipole, then electric potential, and we have discussed electric field. Then special cases of the two special cases which I have discussed here. Two special cases. Now, okay. Now this. Okay. Let me see comment. Okay, good. Okay, you can see the video from beginning. Now this is also important topic, and believe me, if you will solve the question in tomorrow's session, you will find that all the maximum question are asked from dipole. Very important question concept. So we will very important classes for today's very important class. Now let us suppose it is we are having one electric field which is constant. It is electric field is having some value. Let us suppose 2 Newton per coulomb. That it is constant, or we can say as uniform electric field. Uniform electric field. We can say that it is uniform electric field. That is first we are discussing in uniform electric field. We will also discuss non-uniform. Okay, uniform electric field. Now, if suppose we are having dipole here like this, one is having minus q and one side it is having plus q charge. Now, if we are discussing what will be the force on this dipole, you know, force is equal to QE. You know this formula? Force is equal to QE. Earlier we have learned force is equal to QE. We can say that on this charge, force will be along this side QE, and for this force will be along this side, it will be QE. Any problem? Force on this side QE, and they are distance separated by distance d. Let us suppose like this. We can say that net force acting on dipole. Remember, we are talking about uniform dipole, not non-uniform. If it will be non-uniform, then situation will change. So we are discussing about only uniform only. For uniform electric field, net force acting on dipole will be how much? Any answer? How much it will be? It will be plus QE and minus QE, because it is opposite direction. We will get zero force. No force will act. Force acting on the dipole will be zero, first of all. But there will be a torque. You must have learned about the torque in your rotational mechanics chapter. What is torque? Now, let me define one thing. Torque is nothing, but it is a physical quantity which is said as torque is equal to R, distance from a force from a point of force to a reference point, okay, cross F. When we cross product R is a position vector from reference point to point of application, and F is the force. Then we define torque like this. And if equal and opposite forces acts anywhere like this, if it is having force here, if it is having a force here like this, then they the net force zero, but they have rotational force which is called as torque, and we called it as a couple. couple of force is called as force into distance between, perpendicular distance between the forces, and we defined it as a couple, and this is called as torque. Torque of two equal and opposite force is called as couple. You remember when you are opening your tap in basin, kitchen tap, what you do? You apply one force here and one force here by your fingers, then it starts to rotate. That is a torque, but that torque has a special name and we called it as a couple of a torque or couple of a force. Okay, now when we are discussing about torque on dipole, what we will write? We will write it is also called couple, since equal and opposite forces are acting, so we name this torque as a couple, and we say that it is equal to force into perpendicular distance between the forces. Perpendicular distance, let us suppose this is the angle, this is theta angle, made by this dipole from minus q to plus q. We know this is direction of dipole moment P, and this is direction of electric field, and angle between them is theta. We will say that force is QE. You can see force is QE. This is the force. Force is QE into R perpendicular is this. How we will write? This is theta angle. This is 90 degree. If we take sine of this, sine of theta, we will get this with R perpendicular. We will write sine theta is equal to perpendicular. We named it R perpendicular by hypotenuse as D. We can say that R perpendicular is equal to D sine theta. Okay, we will write here D sine theta, or you must have learned in shortcut also. We must be knowing in shortcut also. If any triangle, right angle triangle having theta and here 90 and theta here, and if hypotenuse is given, suppose h, this is always h cos theta, and this is always having h sin theta in 11th class. Okay, now I'm using that only. So from here we know QD can be written as P dipole moment, P dipole moment into E sin theta, and we know AB sin theta is P cross E. So what we got? We got torque of dipole is P cross E. You should remember this formula, and you know how to find the direction of cross product. By that way we can find the direction of torque. This is the formula of torque. You should remember this. Now, second thing, any problem till now? Any problem till now? We can discuss any problem till now. You can ask. I'm waiting for 5 seconds. Okay, let me see. Okay, good. Now, electric potential energy of dipole. What is the electric potential energy of dipole? It is defined as U is equal to minus of P dot E. Remember this formula. It will be very much useful for you. P cross E. This is formula of electric dipole. Electric potential energy of electric dipole. This formula of torque. You should remember this formula. We will be solving some question using this formula. Okay. Now let us move further and see some question. Okay. First, let us discuss this first. Okay. Now, suppose we are having electric field which is non-uniform electric field like this. Electric field is given like this. E is equal to 2x I cap, like this. You remember, you can see here electric field is not uniform. It is depending on x, is non-uniform electric field. So what will happen if we placed any dipole in this? Okay, I will not go to that calculation part because it is important for JEP person, but for NEET we should remember what will happen. We know at this point, this point, electric field, let us suppose Q into E1 here, and it will be here Q into E2. So, and electric field different because it is depending upon X. So here different electric field and there different electric field. So net force on dipole will be not equal to zero, not zero, because it is not, we can say that it is not equal, so we can't say first of all. Second, torque also not equal to zero, but there is one case, if dipole become like this, parallel to electric field, whether it is uniform or non-uniform electric field. Remember, these questions are asked in a certain reasoning type or some conceptual question, language theoretical question. If electric field is this way, such that we are having electric potential like this, we are having dipole like this, such that dipole moment P becomes parallel to electric field. In this case, torque becomes zero. Torque becomes zero. If it is non-uniform, then force may or may not be zero. May or may not be zero. It will be zero only if electric field is constant. But if it is not constant, then it will not be zero. So I have written may or may not be. It will be zero for uniform and not zero for non-uniform. But torque will be zero always whenever P becomes parallel to electric field. Then this is special case and you should remember. Okay, any problem till now? Now let us move further. Fit. Okay. Before going to question, let me take some numericals. I think let me take some question. Then I will go to question part. Okay. Let me take one question. Then I will go to there. Okay. I distribute the pages like this. Suppose I have three figures. One question, good question. It has been asked in JEE also, and it is very much important for your NEET also. Now, suppose there is one electric field, figure 1, another electric field like this, another electric field like this, they are equal, electric field like this, and third case, electric field like this. What it is happening that in first figure, dipole is like this, minus q here, plus q here. Second case, what is happening? It is rotated and it is placed like this, plus q here and minus q here. In third case, what happened? It got rotated like this, such that plus q is here and minus q is here. Electric field is E, electric field is E, electric field is E. First figure, second figure, and third figure. Question is find work done in moving 1 to 2. First question A part, and B part is telling 1 to 3, and C part is telling 2 to 3. Okay. Now, can you try? I will give you 10 seconds. You can try. Instead, you should think what will happen here. You think what will happen? Any idea? Okay, nobody. Now, for first figure, let me calculate that energy, dipole potential energy. What we know that work done will be equal to difference in potential energy, difference in energy obtained. What we will do, we will find the energy, potential energy for first figure, second figure, and third figure. What we will do for first figure, potential energy. What will be the potential energy? We will say like this. We know, we have learned in the previous slide, U is equal to minus P dot E. We will say potential will be minus P. P means QD into E. E is given E. Here in first case you can see that it is having 0 degree. We can write here cos 0 degree. A dot B, AB cos theta. What we will get? We are getting minus QDE. This is first case. Okay. Now second case, we can see that minus a second case from this here minus QDE cos how much? Angle is 90 degree. We can say 90. That means cos 90 0. All will be 0. Third one, we can say that QDE and angle is minus Q2 plus E. This is direction of P. Here direction of P was this. So angle 180 we have taken. Here angle 90 taken. Here 180 because we are seeing that we are having this direction of P and P is 180 degree with electric field. So we will write cos of 180. That means we will get QDE. Now from 1 to E, 1 to 2, what we will do? 1 to 2, what we will do? From that means U2 minus U1. For 1 to 3, what we will do? U3 minus U1. From 2 to 3, U3 minus U2. We will do, put these values and we will get the work done in different configuration or by rotating of electric field. How much work will be done? We can get from here. Any problem till now? Any problem? Okay, nice. Now it is very important question. You should remember this type of question. And I think tomorrow's section we will having a lots of good question. So please join tomorrow's session on time. Now we are discussing now about electric flux. What is electric flux? It is telling that electric flux, let us suppose we are having electric field like this and we are finding the electric field density. What we do? We draw some area like this, some area. Let us suppose this is having area, and you know from class 11th also, okay, area is vector quantity and direction of area will be perpendicular to the surface. This is the direction of area, and suppose area vector is making theta angle with electric field, then we define electric flux is defined as product of this E dot A, or we can say E x theta. This is electric flux. Okay. We also define in terms of field lines, but it is the best description. E cos theta dot product of electric field and area vector. Okay. This is electric flux. Now we are discussing about charge distribution. What is charge distribution? Now we know charge distribution, we can have three types of charge distribution. If we are having linear charge distribution, a rod having charges of plus Q like this. For this, what we will have, we can, let us suppose it has charge Q and length is L. We can define charge distribution here. We set it as linear charge density. And we defined using lambda is equal to Q by L for a system having a linear charge density. Okay. Now, if suppose we are having, this one is first one. If suppose second, we are having some surface like this, any surface, it is having charges Q and surface area is A. We defined it as surface charge density. We defined it like this: surface charge density and we say that, and we denote it with using sigma, and say that sigma is equal to charge on the surface by A. This is called surface charge density. Its unit will be coulomb per meter. Its unit will be coulomb per meter square. And third, third, and third one we can see here. Let us begin. Third, if we are having one volume having charge volume V, and charge is plus Q, then we say volume charge density represented by rho is equal to charge by volume, and it will have unit of coulomb per meter cube. These three are charge distribution. We should remember, one is linear charge density, surface charge density, and third one is volume charge density. And we will be using this for the in our Gauss law also. So let's move further. Any problem till now? We can discuss. Any problem till now? Okay. Now let us move further. It is a very much important topic, and it is a Gauss law. Very important topic, and lots of questions come from here. Gauss law. What does Gauss law tells that? Gauss law tells us, if suppose we are having charges Q1, Q2, Q3, Q4, Q5, Q6, like this, and we have to find electric field at any point here. Let us suppose P point. What we did, Gauss told that for this you have to draw some surface, any surface of your choice. Let us draw, and how much charge you have to enclose, it depends upon you, depends upon your calculation, which makes your calculation easier. Let me take, for my calculation part, I am taking 4 charges under my surface, and this surface is called Gaussian surface. Gaussian surface. What I told, I am repeating once more. There are few charges, Q1 to Q6. First of all, Gauss told that draw the Gauss some surface, including some of the charges which you are able to find easily. Okay, to find the electric field at any point P. Remember one more thing also. If we have to find that electric field, one more thing. Let me tell you here only. Okay, now if we have to find the electric field, suppose at any point P, then that point should be touching the Gaussian surface. Then Gauss told that close integration of electric field which will be present here, and if we take small area, let us suppose this small area is dA. Gauss told that electric field at this point and area dA, he told that if you will take dot product of these two, you will get equal to charge enclosed, how much you have enclosed in this Gaussian surface, by a constant called as epsilon naught, that is permittivity of vacuum. And it's very important. Also, you know that this is flux, because we know d phi is equal to E dot dA. That also we have studied just now. So it can be replaced like this. Integration of d phi is equal to Q enclosed by epsilon naught. Gauss told that net electric field over closed surface, and that closed surface is called as Gaussian surface, and it is equal to net charge enclosed in the Gaussian surface divided by epsilon naught. This is the Gauss law. Remember, this is enclosed charge only. And the electric field we are getting here, E, it is electric field due to all charges Q1, Q2, Q3, Q4, Q5, and Q6. It is due to all charges only. And we have to enclose which charge? Q1 plus Q2 plus Q3 and only Q4. This much charge is enclosed in the surface. but we will get the electric field for whole charge nearby that point. We will get. This is the beauty of Gauss law. Okay. Any problem till now? We will discussing Gauss law. Various questions, type of question it is asked from Gauss law. Any problem till in Gauss law? Any problem? Let me check. Clear. Okay, nice. Nice. Now, application of Gauss law. First application of Gauss law. Gauss told that if we have to now, what we can, we knew that formula of Gauss law is closed integration of E dot dA. By definition, I have written the closed integration in the previous slide. Let me check. I missed closed integration. Closed integration because surface is closed. E dot dA is equal to charge enclosed by epsilon naught. So we can see that using Gauss law, we can find the electric field. That is the beauty of Gauss law. Electric field, we can find the electric field also. That's the beauty of Gauss law. And using that only, this is used in application of Gauss law. We will find the electric field. Now, first example which we are taking is, suppose we have a line charge like this. It is having surface density, that is, linear charge density is lambda, length is L, and charge is Q here. If we want to find electric field at any point here, let us suppose here, what we will do that, Gauss told that, remember the Gauss theorem, Gauss told that if we have to find the electric field at this point, draw any of the shape which is easier for you for calculation, which you can calculate easily. So we know for a linear charge, for a line charge, it is easier calculation is that we should draw a cylinder like this, touching this point. Let us take the length of the cylinder is H, radius is, distance from here is R. We know that electric field will be outside like this. Here electric field will be outside like this. Here electric field will be outside like this. Okay. Also when we are discussing about the area vector, here area vector will be like this, dA. Here area vector will be here, dA, because we know dA and E both are needed here, and here area vector will be like this, dA. If we are using our Gauss law, we will say E dot dA is equal to Q enclosed by epsilon naught. We will say integration E dot dA. For this surface, we are knowing that E and dA are parallel. So we can say E dA cos 0 degree plus, for this angle 90. So we will say E dA 0. For this it will be also 0. We can say here, we can see, so electric field in this direction, electric field in this direction, it is not in this direction, it is in this direction. Angle is 90, here angle is 90. We will say 0, 0, and charge enclosed, since lambda is equal to Q by L, we will say Q is equal to lambda into height is H. We can say here, that means it is E into dA. dA means the area, curved surface area of cylinder. What we will get? We will write 2 pi r into H is equal to lambda into H. When we will cancel, we will get electric field is equal to lambda by 2 pi r, lambda by 2 pi r, and also we can write like this, lambda को replace करके we can write like this, Q by L 2 pi r. Got it? Any problem here? Any problem? Good.